Chapter 3 AI Domains. Artificial intelligence is a field of study in computer science that aims to create intelligent machines that think and react to situations in the same way as human beings. These machines could be a computer, a robot, or a software. Some features that a computer with artificial intelligence would be designed to have include speech recognition, learning, reasoning, problem-solving, and self-correction. An important example of AI technology is machine learning. Machine learning is a feature by which a computer is able to study a situation and act without programming. It focuses on designing computers that can make decisions and predictions and perform a task based on data instead of being programmed to do that particular task in a specific manner. AI is a challenging field because for machines to act and behave like human beings, we need to feed a large amount of information about the world into them. Introducing the concepts of common sense, problem solving, and reasoning are difficult tasks. The research associated with AI is highly technical and advanced. Some people believe that creating machines that are as intelligent as human beings might prove to be dangerous to humanity if left unsupervised. Applications of artificial intelligence. AI technology is popular and finds a large number of unique applications in several fields. Many modern cars have AI-based features such as self-parking and advanced cruise controls. AI is being used by some major automobile manufacturers to develop self-driving cars. AI is being used by the military to develop computers that can assist a pilot in battle by using the data available at that time and calculating the best possible solution. AI is also being used to develop intelligent autopilots for aircrafts that can mimic the behavior of a human pilot even in cases of emergencies. A few AI-based robots have been developed that can teach students subjects such as biology and computer science. AI will find significant applications in the field of education in the near future. AI is also widely used in finance for making trading decisions, market analysis, handling personal finances, and managing make decisions. These are called expert systems. Several countries such as China, Japan, and USA use AI-based robots in heavy industries for jobs that are either too mechanical or too dangerous for humans. AI-based technology is being extensively used in medicine to assist doctors in diagnosing various diseases and in performing surgeries. AI is also being used in cancer research. AI is used in gaming to determine the behavior of various characters in a computer game on the basis of how a player plays. Several toy manufacturers have also developed simple AI-based toys for young children that are able to understand and hold simple conversations with them. Domains of AI. There are basically three domains of AI. They are 1. Data, 2. Computer vision, 3. Natural language processing, NLP. Data science is all about applying mathematical and statistical principles to data. In short, it is the study of data. Let us talk about data in an example of Amazon. When you use the Amazon shopping app for buying products, the application gives you suggestions about what to buy based on your search history or preferences. How do these applications know what you prefer? This is all because of your personal data as well as that of a large number of other users provided to the algorithm. Let us first understand what data is. Data is the core of artificial intelligence. In general, data is a collection of raw facts that can be processed to extract meaningful information. Data can be a piece of information or facts and statistics collected together for reference or analysis. It can be in the form of audio, visual or textual data, numbers, words, symbols. It could include facts, numbers, figures, names or descriptions of objects. For example, test scores of a student, search keywords on Google typed by user, etc. Data is so important today for all applications. It is considered digital capital or digital gold. Data source. Data can be obtained through observations, measurements, studies or analysis. The common data sources are Internet search engines and social media accounts, business systems, government systems, Internet of Things, IoT. Devices are Internet-connected smart devices, such as smart air conditioners and refrigerators. Data as a domain of all data is used to train artificial intelligence models. Data is the key to artificial intelligence. Artificial intelligence needs data to build its intelligence initially, subsequently, and continuously. Whenever you want an algorithm to be able to predict an output, you need to train it first using data. In the above example of Amazon shopping, the algorithm has been initially trained with large volumes of data from users that shop on the website in terms of the products they search for and buy. Based on a user's age, search and purchasing history, the has been trained to recognize patterns in the products they are likely to buy. The algorithm then predicts what another user is also likely to buy based on its training and recommends products to users. Datasets. Related data is grouped into datasets. A dataset is a set of numbers or values that pertain to a specific topic. For example, test scores of students in a class or what a user searched for on the internet on different days. Data types in AL. With reference to AL models, data is of two types: training data and testing data. 1. Training data. Training data is used for training the model, 70% of the data. It is the initial data set that programmers use to teach a machine or machine learning application to recognize patterns and trends. For better efficiency of an AL project, the training data should be relevant and authentic. For example, if the online shopping application is not trained on correct data, the application may recommend products that the user has no interest in buying, and the user may move on to another shopping websites. 2. Testing data. Testing data is used for evaluating the model, 30% of the data. It is used while testing or validating the AL model's accuracy. For example, if the online shopping application is trained on biased data, the application may recommend only a low-cost product to a certain race or gender. This error can be identified during the testing process. Computer vision. As humans, we can see things, analyze them, and then do the required action on the basis of what we see. But can machines do the same? Can machines have the eyes that humans have? If you answered yes, then you are absolutely right. Computer vision is a field of artificial intelligence that trains computers to interpret and understand the visual world. It is like impairing human intelligence and instincts to a computer. In order to teach computers to replicate human vision, programmers use the computer vision domain of artificial intelligence. Computer vision enables computers to see and identify images, processing them the way humans would. Using images from cameras and videos, AL models enable machines to accurately identify and classify the objects as well as interpret and understand the visual world. For example, when you upload a picture on Facebook, Facebook recognizes most of the people in the picture and provides suggestions to tag them. This is possible because of computer vision. The Facebook algorithm first differentiates between the different individuals in the picture and then identifies them by comparing them to existing users. Computer vision (CV) domain of UL focuses on replicating the powerful capabilities of human vision system and enables computers to identify and process objects in images and videos in the same way that humans do. With the help of computer vision, computers derive meaningful information from visual inputs and take actions or make recommendations based on that information. For interpreting the visual world, computer vision uses deep learning algorithms and artificial neural networks. If UL enables computers to think, computer vision enables them to see, observe, and understand. How computer vision works? By using computer vision, UL machines can be trained to perform functions in much less time with the help of cameras, data, and algorithms rather than eyes and brain. The process includes acquiring images, selecting, analyzing, identifying, and extracting information. Acquiring the image. Images, even large sets, can be acquired in real time through video, photos, or 3D technology for analysis. Analyzing the image. Models are pre-trained by being fed thousands of labeled images. They use this knowledge to analyze the image. Produce the result. UL models then interpret and produce the required results or take appropriate action. Applications of computer vision. Computer vision is very important in today's world. Let us look at some important applications of it. Self-driving cars. Detect movements of pedestrians and vehicles. Healthcare. Diagnosis, assistive surgery, drug discovery. Manufacturing. Increase productivity and efficiency. Agriculture. Planting, harvesting, weather analysis. Facial recognition. Security for devices, identification of criminals. Image identification. Compares images, search for images. Automated retail. Stores without cashiers or checkout stations. Robotics. Space missions, rescue missions. Retail stores. One of newest and most innovative applications of computer vision is its use in retail shopping. Amazon Go is an innovative retail store where there are no cashiers or checkout stations. It is a partially automated store that is created by utilizing computer vision. Autonomous vehicles. Self-driving automobiles use computer vision extensively and are amongst the most challenging applications of computer vision. Since in autonomous vehicles, it can be a life or death issue, whether it is for the driver or other road users. Automated cars from companies like Tesla using computer vision can detect the 360 degrees movements of pedestrians, cyclists, vehicles, etc. Facial recognition. Facial recognition is a technology that is capable of identifying or verifying a person from a digital image or a video. It is used as security for unlocking devices and also by investigation agencies to identify criminals. Social media applications like Facebook use it for identifying and tagging people. Natural language processing, NLP. As humans, you use language without much effort because you have been conditioned to understand languages from a young age. This process is quite complex since words can be combined in infinite ways and have different meanings depending on the context they are being used in and the cultural background of the communicators. For example, the meaning of bat is different in the following two sentences. I saw a bat hanging upside down on a tree. The player bought a new bat for the tournament. Humans can master a language quite easily, but the way characteristics and ambiguity of natural languages are the two biggest aspects that make it difficult for a machine to understand and communicate in a natural human language. In order to narrow the communication gap between machines and humans, the natural language processing (NLP) domain of artificial intelligence is used. Natural language processing (NLP) is the ability of machines to understand and interpret human language the way it is written or spoken. NLP helps machines comprehend, interpret, and manipulate natural language used by humans. For example, when you type something on your smartphone using a search engine like Google, it comes up with word suggestions based on what you are currently typing and what you usually type. How NLP works. A typical verbal interaction between an NLP system and a human is given below. NLP is logically divided into two processes. 1. Natural language understanding. NLU helps the machine to interpret data for understanding the meaning of data. It converts text into a machine-readable format. 2. Natural language generation. NLG is a method for creating meaningful sentences in natural language. It automatically produces text or speech from structured data with meaningful phrases and sentences easily understood by humans. For example, when you ask Google Assistant a question, the words or sentences spoken by you into the microphone are taken as input. Google Assistant recognizes your speech and understands it with the help of NLU. It then thinks of possible answers with the help of NLG and gives you the most relevant one as an output. Applications of NLP. The following are the different applications of NLP. Chatbots. Chatbots are programmed to interact with humans in such a way that they sound like humans themselves. They are created using NLP and machine learning, which means that they understand language and also learn from their conversations with humans and become better with time. Chatbots work into simple steps. First, they identify the meaning of the question asked and then answer the question appropriately. Example: HDFC Bank Chatbot. Voice assistants, Siri, Alexa and Google Assistant are common examples of voice assistants that are used to make calls, place reminders, schedule meetings, browse the internet, etc. They use NLP to understand what humans are saying and then act upon it. The goal of voice assistants is to become a bridge between humans and the internet to provide services based on just voice interaction. Autocomplete in search engines. Search engines like Google Search tend to guess what users are typing and automatically complete their sentences. All these suggestions are provided using autocomplete that uses NLP to guess what users want to ask. Search engines use their enormous data sets to analyze what users are typing when they enter particular words and suggest the most common possibilities. Email classification and filtering. Email services like Gmail use NLP to identify whether an email is spam, unwanted, or useful. This ensures that you do not have to be bothered too much by promotional emails.